All right, so here's our practicum problem. So we have 5 points of interest here, 4 pins, and a roller. So each pin is 2 unknowns, roller's 1 unknown. So that gives us, again, a total of 9 to work with. So we're looking for 9 unknowns. That means 3 sets of 3 equations. I'm going to work with the external problem first. Since I've got a pin and a roller, I'll get 3 numbers out of that. And then I'm going to work with the tabletop here, the horizontal piece. And then I'm going to be forced to work with one of the slanted members. There's no choice in this problem. We've only got 1 horizontal member, and we need 2 member free body diagrams to come up with enough equations. So let's start with the external problem here. So I'll redraw the free body diagram. Something looks sort of like that. We've got a pinned support at A, so we have RAX and RAY. We have a roller at B, so we just have RBY. And then we've got 100 pounds down on the top. And we've got 2 feet between A and B and 2 feet between the bottom and the top. We can assume, for simplicity, that everything else is symmetric, so that the 100-pound force is at the middle of the top, that's right above C. So we've got left and right symmetry here. So if we take our sum of forces in the x direction, we have RAX to the right, so positive, and nothing else. So immediately that tells us RAX is 0. You might have already figured that out because there's no side force. So RAX is 0. For our y direction equation, we have RAY up, so it's positive, plus RBY up, also positive, minus 100 down. And that's equal to 0. And then we've got our moments about a point. I'm going to pick A as the pivot point. That'll knock out RAX and RAY. We've got a moment from RBY, and we've got a moment from the 100-pound force. RBY is 2 feet away, so we have 2 RBY. Pinning at A and pushing up at B would be counterclockwise, so positive. The 100-pound force is dead in the middle. That's 1 foot away. So we've got 1 times 100. Pushing down at the top around A, clockwise moment, so negative. That's equal to 0. So we can solve that equation pretty easily. 2 RBY minus 100 equals 0. Add 100 to both sides, and we get 2 RBY equals 100. Divide both sides by 2, and RBY equals 50. And that's pounds. So we've got 50 pounds for RBY. That can help us with our solution for RAY. We've got RAY plus 50 minus 100 is 0. So RAY minus 50 is 0. That means RAY has got to be equal to 50. So RAY is 50 pounds. You might have actually guessed that if you thought about this from symmetry. You've got a 100-pound load dead in the middle on this structure. It makes sense you should have 50 pounds on each side. So we have 50 pounds at A and B. And so that gives us our magnitudes also. So symmetry helps us out quite a bit there. In fact, we should expect some pretty reasonably symmetric values for all of these. What we see at D and E should be the same. To figure out our remaining 6 unknowns, we need to break the structure apart into individual free body diagrams. So we need to break each member apart from the other members. There are three members in this structure. There's the top, where we've got 2 points D and E. We have one slanting one way and one slanting the other. So breaking these apart into three structures, we had a 100-pound force there. This one has joint D, joint C in the middle, and joint B at the bottom. The other one has joint A at the bottom, joint C in the middle, and joint E at the top. So those are our three members. Now we already know what's going on at A. At A, we've got 50 pounds up. We also have 50 pounds up at B. There's no changing that. To draw the free body diagrams, we have to make some assumptions about the forces at C, D, and E. For the tabletop, I'm going to assume, since I haven't worked with D before, I'm going to assume my reactions are positive. So RDX and RDY. I also haven't seen E before, so I'm going to assume REX and REY are both positive. In drawing the free body diagram of one slanted side here, I haven't seen C before, so I'll draw RCX and RCY positive, but I have seen D before. I've already made some assumptions about D, so I've got to make the opposite assumptions when I see D again. So I'm going to draw RDX to the left and RDY down. And then for the final slanted member, I have used C before, so I've got to assume the opposite. So I'll say RCX to the left and RCY down. And I have seen E before, so I'll draw negatives, REX and REY. So there I've got it all. I've got all my assumptions consistent with each other. I'm taking into account Newton's second law at each of these joints. Wherever a joint is used in more than one free body diagram, it's got to have equal but opposite directions. So equal force, opposite directions. So the D here, left and down, D here, up and to the right. E up and to the right, E over here, down and to the left. Equal but opposite. That makes sure that whatever numbers I get from one free body diagram, I can just move over into another without having to worry about signs. I've already done my worrying about the signs. So let's start with the horizontal member. For the horizontal member, I'll move that over to another page here for clarity. So I've got 100 pounds dead in the middle. I've got RDX and RDY positive. And then I've got REX and REY positive. So joints D and E. Now, because this is a horizontal member, I should expect to get two numbers and one equation. I've got 4 unknowns and only 3 equations. So that means I'm going to get potentially 3 equations in those 4 unknowns. But the advantage of working with a horizontal member is that when I take my pivot point for my moment equation, I'm going to knock out everything except one unknown. That's going to give me one number, and I'll be able to solve for one of the other values. So I'll end up with one equation I can't use just yet, but 2 numbers. So let's take our sum of forces in the x direction. I have RDX to the right, so that's positive, plus REX to the right, also positive. In the y direction, I've got RDY up, so that's positive. REY up, that's also positive. And then I've got 100 pounds down, so that's negative. And then I have my sum of moments. I'm going to pick joint D as my pivot point. So that'll knock out RDX and RDY. It'll also knock out REX, since the line of action of REX goes through D. Only REY and the 100-pound force will have a moment. Well, REY is 2 feet away, so it'll be 2 REY. Pinning at D, pushing up at E, that's counterclockwise, so positive. And then I've got 1 foot away, 100-pound force. Down is going to cause a clockwise moment, so that's negative. So we have 2 REY minus 100 equals 0. So 2 REY equals 100 if I add 100 to both sides. Divide both sides by 2, and REY equals 50. So REY equals 50 pounds. So we can fill that in on the table. REY is 50 pounds. That'll also help us solve our y direction equation. I have RDY plus 50 minus 100 equals 0. That's RDY minus 50 equals 0. And adding 50 to both sides, RDY equals 50. So RDY is 50, and we can fill that in. Unfortunately, we can't do much about the x direction equation. RDX plus REX equals 0. The best we can do is put that in our equation bank and hope we can use it later. So RDX plus REX equals 0. So that's the free body diagram and the solution for the tabletop. Now let's do one of the slanted members, and I'm going to just arbitrarily select the member AE to work with. Either one's going to be about the same difficulty to work with. We have REY and REX at E. Right here in the middle at C, we have RCY and RCX. And then at A, we've got 50 pounds up. So member AE. So let's do our sum of forces. Sum of forces in the x direction. We've got a negative REX and a negative RCX. Nothing else in the x direction. In the y direction, we've got a negative REY minus RCY plus 50 equals 0. So those are our y's. And then we've got to pick our pivot point for our moment. Now, because this is a slanted member, the only forces we'll be able to knock out will be the forces at the pivot point. So it's going to come down to a choice between using C or using E. Now, from the previous problem that we just did from the tabletop, we figured out something going on at E. So if I'm going to have some forces stick around, I'd rather have E stick around. If I pick my pivot point at E, I'm going to knock out one unknown force, but I'm also going to knock out one known force. I'd rather knock out 2 unknown forces. So joint C is going to be my choice here for our pivot point because I don't know anything about C. I don't know RCY or RCX. So I'm going to pick C as my pivot point to maximize the amount of unknown information that I knock out. So I'm going to pick joint C as my pivot point. That means no moment for RCX or RCY. I will have a moment for REY and REX because both of those will have arms compared to point C. And I will have a moment from the 50-pound force at A. But at least I'll only have one unknown. I'll only have REX as my unknown. That'll make the equation a little easier to solve. So let's work through that. Let's take the 50-pound force first. The line of action for that goes straight up. And there's a 1 foot distance between joint C and A. So we have 1 times 50, that's just 50. If we're pinning at C and pushing up at A, that's a clockwise rotation, so negative. Let's do REY next. REY is also 1 foot away, so it's just REY. If we're pinning at C and pulling down at E, that's clockwise, so negative. And then we've got REX. REX is 1 foot above, so it's also just REX times 1. But if we're pinning at C and pulling to the left at E, that's counterclockwise, so positive. So there's our moment equation. And we can use our table to fill in what we know. We know REY. So everywhere where we see REY, we can fill in what REY is, 50 pounds. So we have REY, that's 50. Don't forget that negative out there though. REY here is 50. So let's go ahead and solve. In the moment equation, we've got negative 50 minus 50 plus REX is 0. Negative 50 minus 50 is negative 100. Plus REX is 0. Add 100 to both sides, and REX is 100. So REX has a force of 100 pounds on it. So that's REX. So we get 100 pounds of force on REX. That also lets us solve our y direction equation. Our x direction equation, excuse me, we have negative 100 minus RCX equals 0. If we add 100 to both sides, we have negative 100, negative RCX equals a positive 100. And dividing both sides by negative 1, that'll just flip the signs here. RCX is negative 100. So RCX, negative 100. And then finally, we've got RCY. Negative 50 plus 50 is 0. So we get negative RCY is 0. And that means RCY has got to be 0. The negative of a number is 0. That number is still 0. So RCY is 0. So there's our solution for our slanted AE table leg. If we go back to our table, we're missing everything except one piece, or we've got everything except one piece, RDX. But we've got an equation we haven't used yet. RDX plus REX is 0. Well, REX we now know is 100. So we have RDX plus 100 equals 0. That means RDX is equal to negative 100. So RDX is negative 100. Almost done. All we have to do is find our magnitudes. Fortunately, 3 of those magnitudes are pretty easy because we only have one component. 50 pounds, 50 pounds. And this one, be careful here, magnitudes are always positive. The magnitude is the square root of x squared plus y squared. That gets rid of the signs. So we have a magnitude of 100 there. But for D and E, we actually have to calculate those. So if we take 100 squared and add it to 50 squared, taking the square root, we get 111.80. And that's going to be the same on both of those. So there's our solution. Of course, if we had to round to an appropriate number of significant figures, now would be the time to do that with our final answers. So that's our final frame example.